All right, hello. So I want to go over this problem with you. It's a step forward. So we've been dealing with rational expressions, simplifying rational expressions. This is really a rational equation because it says equal, so it's made up of rational expressions, fractions, but this is going to be equal. So we're going to be solving for x. One of the reasons I want to show you this is so that you can start getting to look at some harder stuff too, so you can work on some of those mechanics that we went over, like in the last video. How do those things come together? And really, so you can start like exploring how to work on these on your own, because a lot of this is just experience. A lot of it is seeing these kind of things over and over and over again. All right, so let's dive in. And one of the things I want you to see as well is this is going to require a lot of steps. And you're just at that point in algebra that things are not quick and easy. And I want you to avoid the mistake that most students make, is that of wanting to be quick and easy. So they'll just skip a bunch of steps thinking that that's okay, and it's not. So a lot of the math you're going to be encountering now is what we call methodical. So you're just going to have to go through the steps and do things and undo things. And you're going to see it in this problem. We're going to do stuff to make things simpler, but it seems to make things more complicated. But in the end, it actually does it more. It's a simpler way of doing things. It just sometimes doesn't feel that way. So let's take a look at this. And first thing first is you go, oh, gross. Not going to lie. Most people do not like working with fractions. And so we want to go ahead and get rid of the fractions, is one of the things that is a thing we can do, so that we can make things easier. And it's conceptually, like it's easier to imagine 4 candy bars than it is to imagine 1/64th of a candy bar. So yes, we'd like to get rid of the fractions so that we can see what's happening more easily. So how do we do that? Well, we have an equation. Remember, we can do anything we want to an equation, as long as we do it at both sides. And so we're going to use that principle here. We are going to get rid of, and it also works out that both denominators, the bottom numbers, are x minus 1. So we can get rid of these by creating a fraction that's x minus 1. And the easy way to create that fraction, so we don't have to do more work in the denominator, is to just put x minus 1 over itself. Because x minus 1 and x minus 1 over 1 are the exact same thing. So we'll see here. That's not what we want to do. X minus 1 over 1. All right, and you can see that these two things here cancel out. So I no longer have to deal with this. This right here, we're going to just leave it, but it cancels out as well. And I'll show you why we have to leave it. But the important thing is that it makes that x plus 3 just drop down. So x plus 3 is a lot easier to deal with than x plus 3 over x minus 1. Now, the unfortunate part is we can't just go, okay, cool, we're done. We took care of the problem. We do still have to multiply this by everything. So that means we have to multiply these two parts together, which is going to expand things out and make it look like it's not making things easier for a moment, but it's just the math, and we have to do it. So we're going to use that foiling method where we do x times x squared, x times 5, and we'll go through that. Now, keep in mind, we can't cancel out this way. You can't cancel out that x with that x because this is a term. We can only cancel out factors, so multiplication, division, not addition. All right, so that x right there has to stay the same. So whatever we're coming up with on the top is going to be over x. All right, so let's do it. X times x x squared. Because remember, when we multiply exponents and there's really an exponent of 1 over each one of them, we were actually adding them kind of in a kind of simplified form. X times 3. Remember, when we multiply constant with the variable, we kind of just smush them together, and we kind of prefer our constant in front of the variable, so we get 3x. Negative 1 times x is going to be negative x. So let's go ahead. Well, let me go ahead and write this up. Before we move the next step, let's go ahead and just clean this up. 3x minus x is 2x. So let's go ahead and just clean that up now. So we did 2 steps at once. All right, we still need to do this negative 1 times 5, which is negative 5. So we have this negative, we have x squared plus 2x minus 5 still over x. We still have the right-hand side to go over. All right, so we're going to go ahead and multiply, because whatever we do to one side, we have to do to the other. We're going to multiply this side by x minus 1 over 1. All right, and the awesome thing is these cancel out, so we don't need to worry about those. And it just pretty much just drops that 3x plus 1 to the bottom. So we're little by little getting rid of these fractions so that things look a little easier for us and that we can process them. So 3x plus 1, we just drop that at the bottom. Okay, we still have this one here, though, to deal with. And we're going to do the same thing. We're going to create something to multiply by to kind of just drop it down. And since we want to cancel out the x, we're going to multiply both sides by x over 1. So we're going to use that. That's going to be a handy trick to kind of just do over and over. So we're going to have x over, oops, x over 1. I know I'm writing over things. And x over 1, because what we do to one side, we have to do the other. All right, well, what we have to do is multiply everything on this left-hand side. We can't just say that's only for this. We are multiplying in x. Now remember, x over 1 is the same as x, so we're going to jump back and forth on that one. X times x is going to be x squared. X times 3 is going to be 3x. Now here, this is why we wanted it, was to use this. X over 1 times x, those are going to cancel out and just going to drop this whole expression down. So we just have to rewrite it, is all we're going to do, is plus x squared plus 2x minus 5. I know I write like a 5-year-old. All right, so over here on this one, we're going to multiply all by x, and really we don't need the over 1. So 3x times x, and so this is kind of a good review of when we're multiplying these x's, we're just going to bring the 3 along. We're not doing the 3 times x, we're doing x times x. So the constant's going to stay the same, but that x is going to become an x squared. And then x times 1, anything times 1, it remains itself. So we get x. All right, so believe it or not, that's a lot easier to work with. What I'm going to want to do next is clean this side up, because we have a lot going on over here. So we're going to combine like terms. All right, so I have an x squared and x squared. Those are like terms. Remember, an x and an x squared are not like terms. X squared and x squared are like terms. So how many x squares do I have? I have 2x squares. So 2x squared. I'm just gonna make a little, I'm gonna cross them out because I already combined them. All right, so then we have x's, and I have a 3x and a 2x. 3x plus 2x is gonna be 5x. So this is starting to clean up. There's no other constants, so -5. So what we cleaned that up to 2x squared plus 5x minus 5. We don't have anything to combine on the right-hand side. So that's just going to stay the same. That's going to stay as our 3x squared plus x. All right. So we have this now. And what we're going to do, so I'm going to go ahead and transfer that over because I don't think it'll let me. We have 2x squared plus 5x, and this will give you time to catch up on some writing on your own. 2x squared plus 5x minus 5. 2x squared plus 5x minus 5. And you're going, oh my goodness, this is so much work. I sometimes have 5 pages of things. If I'm lucky. So I will trade you any day. Equals 3x squared plus x. (3x squared plus x). So keep in mind, we're trying to solve for x, but we have all these x's everywhere. Like we have x squares, we have x, we have constant. But remember, we've worked on our quadratics before. The quadratics were the ones that started with x square. And remember how on a couple examples, we set those to 0. So we can do the same thing. We can set that to 0, meaning we could get all this over here. So I'm going to break that into a couple of steps. You can really just subtract the whole side. But I wanted to break that up in a couple of steps. So to turn this to 0, I need the opposite. Because 3x squared minus 3x squared is 0. And that's what we want. But whatever we do to one side, we have to do to the other. So I'm going to just line it up here. We are subtracting, oops, I did it again. 3x squared from both sides. Okay, well, I want to get rid of this x too. Wondering if you can hear my dog snoring in the background. So the opposite of x is -x. X minus x would be 0, which would turn all this to 0, and that's what we want. So, but what I do to one side, I have to do the other. We're subtracting x, so I'm going to subtract an x over here. All right, and really over here, we're doing -3x squared minus x, just so that we can show that. Right. So we'll start on the right because it's just easier. 3x squared minus 3x squared is 0. X minus x is 0. So we have 0 over here. That's exactly what we wanted for our quadratic. So it equals 0. Over here, we're going to do we're going to do 2x squared minus 3x squared, which gives us -x squared. And then here, a little simpler, we're going to go 5x minus x gives us 4x. We're not dealing with that constant. So we're just going to drag it on down. All right, so we've really simplified this. We're at -x squared plus 4x minus 5 equals 0. Now you don't have to do this before we do the quadratics, but we're gonna change the signs, and we're changing the signs. Essentially, we're factoring out a -1. All right, because if we took out -1, if we factor out -1. Right? and everything else was in parentheses, we actually changed that to x squared. All right, because -1 times x squared would be square. So it's a little trick to change signs to have them be what you want, but you have to do them with all these signs. So essentially, I'm changing all these signs. So instead of 4x, that's now -4x, and that becomes +5. And it still equals 0. Because we're still multiplying the right-hand side by -1, but 0 times -1 is 0. All right, now we're trying to solve for x, so we kind of just ignore the -1. It's still there, but when we factor this into a quadratic, remember how when we had the parentheses, we were concerned with finding 0 because we just needed the opposite to whatever the other piece was. That made it equal 0. So we really kind of just ignore the -1 now that we've used it to change our signs. And now we have to do the parentheses method to find those zeros. So hopefully you remember, because it's going to be a very important skill. And so remember, when we see our quadratic, we just write our parentheses automatically. And in this case, because there's no coefficient in front of the x squared, that's going to be a thing we go over. And in the video I'll list for someone else, they will go over that example. But for now, we just put our x's. Now we need a number. We need two numbers, because remember, we put a number here, we put a number there, that is going to multiply to be 5, but when added will equal 4, or equal -4, more importantly, or else it might not happen. Well, and again, this is experience, and it takes a while to kind of get used to doing these things. I just happen to think a good number to try are 5 and 1, because 1 times 5 will equal 5. But 5 minus 1 equals 4. So that means that 1 has to be a negative. So let's do -1 and +5. And because we're in algebra, we're going to FOIL these out just to double check, make sure that that's our correct answer. So x times x is going to be x squared. X times 5 is going to be 5x. And then -1 times x is x, negative x. We can already see, because 5x minus x is going to be 4x. Okay, so maybe we want it reversed. And see how I say, like, it sometimes, so -4, because we wanted to get to -4x. I'm glad I made that mistake so that you could see it. So we actually want +1 and -5. So we're switching the signs. I'm glad I made that mistake, because then we want negative. So -5x plus x would be -4x. And then 5. Two numbers are going to be positive. 5, how do we get that? That would be negative. You can't have two positive numbers, because two positive numbers wouldn't equal 4. 2 and 3 equals 5. But if you added 2 and 3 together or multiply them, they equal 6. Did I copy the problem down correctly? +5. And that's where we made the mistake. So again, I'm glad you're seeing this, because it's probably one of the biggest ways that mistakes happen is that we make errors in our signs. And so when I transferred that -5 over, and I just want to double check. So this was at 1 point x plus 5. I messed up the sign. So that should be x plus 5, which absolutely changes everything. Because this would, if this was a positive the whole time, then it would change negative here when we subtract out that 5. And then so two numbers that add to 5 would be -5, +1. And then that's x squared. That would be -5x, x, +1 times negative would be the -5 we needed. So this all adds up, and I'm glad missing a sign or accidentally changing a sign or forgetting to do the sign is going to be like your #1 source of getting something incorrect. And it happens for everyone starting off in algebra to very linear equations, to simple mistakes of doing things in pencil. And is that mark on the paper a negative sign, or is it just a mark? So this actually, when we work it out, turns out to be x squared 5 times it was -5x and then 1. And even as a math teacher, now my confidence is shaken. 5 is -5, which is what we wanted. And then if we combine these like terms, -5 plus x is actually 4x. So I'm going to go write that on the next page. X squared -4x, x squared -4x minus 5. But I will repeat, I'm glad you saw that mistake so you can see where the mistakes are happening. Okay, and you can see that math teachers are not perfect. We make mistakes. So it's okay for you to make mistakes. Like nothing happened. Everything's okay. So it all comes back. I do want my parentheses that I was working on. So it's going to be x plus 1, x minus 5 is what we factored it out to. X minus 1, x plus 5, all that detour. But I'm glad it happened. Kind of. So remember, we were doing the opposites. 1 minus 1 would make that 0. Over here, -5 would make it 0. So my answers are 1 and -5 because those are the two numbers that would make this 0 and would make this true. So x equals 1 and -5. However, last step, we do need to go back to the beginning. Remember we did in the other video where we were checking for zeros? If we look back at where we started from, this denominator cannot be 0. So that means it can't be 0 here. X just can't be 0. X also can't be 1 because 1 minus 1 would be 0. That is one of our answers here. So it can't be 1. So we're just going to go ahead and throw that away. That's just not a thing. Our answer is x equals -5. So quick recap. This was how to do a rational expression. There's a lot of steps. So I'm sorry, like that's you're just where you're at in math now. Is algebra requires lots of steps and requires a lot of time. We covered simplifying rational expressions, checking for zeros for what it can and cannot be, quadratic equation factoring. We also covered making mistakes. So watch your signs. I did not. They can happen in many different ways. It can happen in you made an error in your math. It could happen in you flipped the page like I just did, and instead of putting down a plus, you put a minus. It could happen if you're writing things down that a mark looks like minus, and trust me, that happens so much. And you don't know if it's a pencil mark or a negative. So really, and I know this is hypocritical of me, being really neat when you're doing your math on paper really helps. And my handwriting does not follow that. But it'll help you from making those mistakes. And you saw it cut me off guard. And quite honestly, after I made that mistake, it shook my confidence. I was very unsure if I was going to go. I almost turned off the video and started from start. So watch those signs. Again, like incorrect signs is like one of the largest problems, whether you're starting in algebra or whether you've been doing math forever. The sign changes will constantly be where the source of issues occur. So I hope you learned something from this video. I hope you laughed at me making a mistake, because that's okay. And I'll see you soon.